This is the Section 9 chapter or Section 1 notes day 1 video. Chapter 9 is going to be all about quadratic functions. So we kind of need to know, what is a quadratic function? Well, a quadratic function is a function with a degree of 2. That means the exponent, the highest exponent, is 2. So this can look like something like w equals 3x to the second, y equals 2x to the second plus 9, or y equals x to the second minus x plus 2. Any of those can be quadratic functions because the highest exponent is going to be a 2. The quadratic parent function is the simplest possible quadratic function, and that is y equals x to the second. Doesn't get any simpler. There are no numbers. It's just two letters, y equals, and then x to the second. A parabola is the graph of a quadratic function, and this is always going to be a U-shaped graph. So a parabola is a graph of a quadratic function. So it's either going to look like what I think of as a smiley face, going up the arrows are, or a frowny face going down with the arrows. Either way, it'll look like a U. Next is the axis of symmetry. This is located on the graph. All of these U-shaped parabolas are going to be symmetrical. The axis of symmetry is the line of symmetry that divides the parabola exactly in half. So here are a couple examples of the parabola being divided exactly in half. These are the axis of symmetries. The vertex is a point on this parabola that is going to be the highest or the lowest point. If it's a smiley face, you're going to have a low point as a vertex. If it's a frowny face, you're going to have a vertex that has a high point, or what's going to be called a maximum. If a parabola opens up, your U shape is going to be a smiley face. Okay, so it faces upwards. The arrows point up. Okay, this ends up having a vertex, which is a minimum. That is known as the lowest point. In the actual equation, the very first number in front of the x to the second is going to be larger than 0. So it'll be a positive number. So it might be 2x squared, okay, or it might be 17x squared. Anything that is a positive number will cause this to be an open parabola. The opposite of that is, well, what happens if you have a N shape or a frowny face parabola? You will end up with a point of the vertex that is a maximum. That's the highest point possible on the graph. In the equation, you'll notice that that number in front of x to the second is less than 0. So that's going to be a negative number. So like negative 2 x to the second, or negative 5 x to the second. That very first number attached to the x to the second, if it is less than 0 or negative, you'll end up with a graph that looks like a frowny face, or the arrows that point down. The domain we talked about in the very first semester, but it's been a little bit. Domain are the x values. So that's always the x, y goes left to right. So you're looking at the left to right values. In a parabola, so in all of these equations, the domain will always be all real numbers. Now we abbreviate that with a capital R with 2 backs to it. So that's our sign for all real numbers. And that's going to be the domain for every single one of our parabolas. The range is the y values, and that depends on where the minimum or the maximum is. So if you have a point here that's the vertex, that's a minimum, all of the values for the graph of that parabola, of that curve, that smiley face, are going to be greater than or equal to that lowest point. You won't have anything lower than that, but all of the points above there will work as possible answers. On the other hand, if you have a downward facing graph, you'll have a high point at the vertex. So in this case, your range would be all those y values would have to be less than or equal to 0, because 0 is the very highest point. Okay. So moving on to problems, these have actually been graphed for you. So they're asking, what are the coordinates of the vertex of each graph? Is it a minimum or a maximum? So I can see just from the graphs themselves that on A, I'm going to have a maximum, I have a high point, and on B, I'll have a minimum or a low point, just based off the shapes of the graphs. Now to find the actual vertex, I just have to find the coordinate, the xy coordinate, of that minimum or maximum. So on this one, it'll be a maximum and it's at 0, up 1, 2, 3. So the vertex will be at 0, 3. On this other one, from the center, I go over 1, down 1, so that'll be a vertex of 1, negative 1. So you need to have both pieces of information, the vertex point, and then label it whether it's a maximum or a minimum. Go ahead and flip this page over. Now we're going to be graphing, and we're going to be talking about domain and range. So for problem number 1, it's saying graph the function y equals 1/3 x to the second minus 1. So I already have my table set up. And for my x values, I'm always going to use -1, 0, 1, and 2. So I already plugged those into those equations. Now I can use my calculator and plug this in just as it is, making sure I use parentheses around the number that I'm plugging in. And when I do that, I'll get a y value for this first one of -2/3. When I plug 0 in, I'll get -1. 1 in will get me another -2/3. And 2 will get me 1/3. So these are the points that I'm going to graph. -1, -2/3, 0, -1, 1, -2/3, and 2, 1/3. So they're going to be very, very close together. So this first one, I'll go -1, down 2/3, put a dot there. Then at 0, I'll go down 1 whole 1. And then I'll go over 1, again down to -2/3, and then over 2, up to 1/3. And you should see that this is going to be a smiley face. So that's my parabola. I'm just going to connect the dots. I'm going to make sure to continue it so I get my whole smile. Okay, so that is the graph of this function. Next is to find the domain. Now the domain is going to be all real numbers, which again is that capital R with the double back. The range has to do with the very lowest point. So on this graph, the very lowest point happened at 0. And the y value there was a -1. So I'm going to have my y value with the -1. Now I have to figure out if my sign should be a greater than or equal to sign or a less than or equal to sign. And this goes back to the equation. Is this number, the 1/3, bigger than 1 or bigger than 0 or less than 0? So it is a positive number. If it's a positive, then it's going to be greater than or equal to. If it's a negative, it'll be less than or equal to. So you might want to write a note. Positive a value, we call that first number a. This would be a negative a value.